In this question, we want to solve the following logarithmic equation. Log base 3 of x plus 7 minus 3 equals negative log base 3 of x plus 13. So we've learned two methods for solving logarithmic equations. So I want to take a look at each one of them. One of the methods is to convert to an exponential. So when you convert to an exponential, you typically will have the log only on one side of the equation. And you use the definition of the log to convert it to an exponential equation. So the base of the log becomes the base of the exponent. The log equals the exponent, and the exponential expression equals the value inside of the log. The other method that we've learned for solving log equations is a one-to-one property of logarithms, and some books call that the property of equality. And with this type, or using this method, you would typically have log base b on one side and log base b on the other side. So you would have a log with the same base on each side of the equation, and once you have that, because of this one-to-one property, you can say that what's inside the log on the left has to equal what's inside the log on the right. It allows you to eliminate the logs from the equation. As we look at the example that we have, you can see that this doesn't really fit into either of these. First, we notice that we have logs on both sides. However, this minus 3 doesn't, it kind of throws a wrench into it fitting this format where you have a single log on the left and a single log on the right. This extra term means it doesn't fit that format. It also doesn't fit this format because you have logs on both sides of the equation instead of having a log on just one side. So what that means is that we need to do a little bit of work before we are able to implement one of these methods. So what I'm going to do is I'm going to move this term that has a log in it to the other side of the equation so that they're on the same side. And so eventually we'll be able to use this method of converting to an exponential. So if I subtract log base 3 of x plus 7 on both sides, that's going to be a little bit messy, so I'm going to try something different. What I'm going to do is I'm going to add 3 to both sides. So I'm moving that term to the other side, and then I'm going to add this log onto the other side. So it will look like this. Log base 3 of x plus 7 equals 3 minus log base 3 of x plus 13. And now I'm going to add log base 3 of x plus 13 on both sides. And that gives log base 3 of x plus 7 plus log base 3 of x plus 13 equals 3. And now I have two logs on the same side, and I'm going to be able to condense these with the product rule for logarithms. So this becomes log base 3 of x plus 7 times x plus 13 equals 3. And now that I've condensed to have a single log on the left, I'm going to be able to rewrite this log equation as an exponential equation. So I'm going to use the base of the log, it's base 3. The log always equals the exponent. We have a power of 3. And then this exponential expression will equal the expression we have inside the log. That's x plus 7 times x plus 13. So now that we've converted this to an exponential expression, or excuse me, equation, we're going to be able to solve it. 3 to the third power is 27. We're going to multiply x plus 3 times x plus 13. That's x squared plus 13x plus 7x plus, and I don't know in my head what 13 times 7 is. So we have 91, and that's 27 equals x squared plus 20x plus 91. I'm going to subtract 27 on both sides. That gives x equals x squared, excuse me, 0 equals x squared plus 20x. If I do that subtraction, I need to borrow from the 9. And 11 minus 7 would be 4. So we have a plus 64. And I'm going to see if I can factor this. So let's try that, x and x. Let's see, factors of 64 are 1 and 64, 2 and 32. 3 doesn't go in there. How about 4? 4 times 16. 4 and 16 can make a 20. So I've got a plus 4 and a plus 16. And I'm able to set each one of these factors equal to 0 and get x equals negative 4 and x equals negative 16. Now, logarithmic expressions have restricted domains. Log of a positive is defined, but log of a negative and log of 0 are undefined. So anytime we solve a logarithmic equation, we need to check to make sure that our answer fits into the domain of the logarithmic expressions that we have. So I'm going to check, and I'm going to zoom out here so we can see the original equation again. So I have that original equation written down right here. Actually, that might not be the original. Okay, so this is the original equation here. And I'm going to check to make sure that x equals negative 4 is in the domain of each one of these expressions. We have log base 3 of negative 4 plus 7 minus 3 equals negative log base 3 of negative 4 plus 13. So I'm focusing on what's inside the log. Negative 4 plus 7 is a positive 3. Negative 4 plus 13 is a positive 9. And so we're going to be able to keep that solution of negative 4. So then let's check the other one. X equals negative 16. That would give log base 3 of negative 16 plus 7 minus 3 equals negative log base 3 of negative 16 plus 13. And you can see that inside this expression here, negative 16 plus 7, that's going to give a negative number. Log of a negative is undefined, so we have to throw that solution of negative 16 away. So the only solution to this logarithmic equation is x equals negative 4. Thank you for checking out my videos. Have a great day.